In this section, we're going to be solving systems by elimination. So we're going to start off with an example, doing elimination using addition. We have two equations, x minus 2y equals 19, and 5x plus 2y equals 1. We're going to solve them by using elimination. So the first step in solving this using elimination is to look at what you have. You see that you have a negative 2y and a positive 2y. So we know that if we were to add the two lines together, those two would cancel each other out, which is what we're trying to look for. We're trying to cancel out one of the variables, either the x or the y. Because we are able to cancel out the negative 2y and the y variable when we add the two equations together, we can go ahead and add the two lines. When we add, we just add straight down. So x plus 5x is going to give us 6x. Negative 2y plus 2y cancels out to become 0, equals negative 19 plus 1 equals negative 18. So we're left with 6x equals negative 18. Now we want to isolate the x variable in order to solve for it. To do this, we have to divide both sides by 6. That leaves us with 1x on the left and negative 3 on the right. So we know what x equals, so we can take the x value that we have and plug it back into the first equation for x. So negative 3 minus 2y equals negative 19. Now we want to solve for 2y, so we want to isolate the variable. In order to do that, we must start by adding 3 to both sides. When we add 3 to both sides, we're left with negative 2y equals negative 16. Then, in order to finally isolate the y, we have to divide both sides by negative 2. Dividing the left by negative 2 gives us a positive 1y equals 8. So our solution, the ordered pair, would be negative 3, 8. Now we're going to look at a similar example, except this time you're going to have to use subtraction with the elimination process. We have two equations, 3x plus 4y equals 18, and negative 2x plus 4y equals 8. We can see that we have two common terms, 4y and 4y, but we cannot add them because 4y plus 4y would just give us 8y. So we have to make one of the 4y's negative. We're going to change the bottom row to negative 4y. But in order to do this, we have to multiply everything in the bottom row by a negative. So when we multiply every term in the bottom row by negative, we get a positive 2x. We would get a negative 4y, and then we would get a negative 8. Once we multiply all the terms in the bottom row by a negative, we can see that the two 4y's will eventually cancel out. Okay, so now we're going to go ahead and simplify. If we have 3x plus 2x, we get 5x. The reason we're adding now is because we've already distributed negative. 4y plus negative 4y gives us a 0, and then 18 plus negative 8 gives us 10. So now we want to solve for x variable. We have 5x equals 10. In order to solve for isolate x, we have to divide both sides by 5, which leaves us with x equals 2. Now that we know what x equals, we can take the x value that we have and plug it back into the second equation. So we see the second equation is negative 2x plus 4y equals 8. We're going to go ahead and plug in the 2 for the x, so negative 2 times 2 plus 4y equals 8. That simplified would be negative 4 plus 4y equals 8. Then we want to isolate the y variable, so we're going to add 4 to both sides. That would cancel out the 4's, leaving us with 4y equals 12. Then finally, in order to isolate the y variable, we have to divide both sides by 4. When we divide the left side by 4, that leaves us with 1y. When we divide the right side, we get 3, so y equals 3, and the solution order pair would be 2, 3. Now we're going to look at a final example of using elimination. This time you're going to have to multiply one equation before you can eliminate. So we have the two equations, 2x plus y equals 3. And we have negative x plus 3y equals negative 12. Here we can see that we have no terms that are the same. So we have to multiply one row in order to create terms that are the same. Because we have a negative x in the bottom row, we're going to multiply the bottom row by 2, because that would then give us a 2x and a negative 2x, which can cancel out. So let's go ahead and multiply the entire bottom row by 2. So we have, let's keep the first row, 2x plus y equals 3, and then we're going to multiply the entire bottom row by 2. So our new system of equations would be 2x plus y equals 3 over negative 2x plus 6y equals negative 24. Now we can go ahead and add the terms. When we add, the 2x and the negative 2x cancel each other out, which gives us 0. Then y plus 6y is going to give us 7y. 3 plus negative 24 is going to give us negative 21. So now we can go ahead and solve for the y variable. In order to do that, we have to divide both sides by 7. When we divide the left side by 7, we're left with 1y. And when we divide the right, we're left with negative 3. So y equals negative 3. We can now take the y value and plug it back into the first equation in order to solve for the x variable. So 2x plus y, which in this case would be negative 3, now we can go ahead and simplify the equation by moving the negative 3 to the right side. So we add 3 to both sides, which leaves us with 2x equals 6. Now we can isolate the x variable by dividing both sides by 2. We divide by 2 in order to give us 1x on the left, which would then give us 3 on the right. So x equals 3, and our solution set is now 3, negative 3.